last lesson of the chapter. There'll be some review videos that'll start popping up Wednesday evening and some other ones on Thursday. So we're going to look at systems of linear inequalities. And I just want to throw this out there that these will be multiple choice on your test. So you don't have to show a bunch of work or anything like that like you do with the substitution and elimination ones. So if you can kind of figure these out, you should be good to go. Anyway, we're doing the same thing we did yesterday, so you need to go back and watch yesterday's video in order to understand what we're doing. So as a reminder, when they're like this, with the greater than or equal to, less than or equal to, that's a solid line. And when they're like this, without the equal to part, it's a dashed line. And then also when it's a greater than or equal to, we shade above. When they're less thans or less than or equal to, we shade below. I think most of you that uploaded those yesterday seem to be getting a hang of it. So I'll go through some examples today. So now that we have two of them, it says that solutions to a system of inequalities, I'm up here at the top, are ordered pairs that make all of these inequalities true. We're on page 27 if you needed to figure that out, but it's uploaded in Google Classroom, so you should be good to go. Anyway, let's graph this one. Y is greater than x minus 2. So I'll do this one in red. So I come down to -2, and it is a dotted line. And our slope is 1, so it's just going up like this. And since it's a greater than, we would shade anything that's above it. One thing I noticed yesterday when you guys were graphing these, you can't scribble over top of this because then I can't tell if it's dotted or not. Leave a little bit of room so that I can tell really that it's a dotted line, as I went over it there a little bit. But my other one is -x plus 1, if I wrote that in slope-intercept form, less than or equal to, so it's a solid line. So we go to 1, and I'm going to change my color. So I go to 1. My slope is -1. So we're just going to go down. Now this one here, since it's an equal to, is a solid line. And it is a less than or equal to, so we shade below. So I guess we got some Christmas here in February. So what is our solution? Let me see what other colors we got here. Let's see if this works. This is not, nope, that's not going to work. Where's our solution? That's not the solution there because that only satisfies the first equation. This is not the solution because this area right here only satisfies the second equation. But then everything over here works for both. That's where your solution would be. So let's do another one. So I'm going to stick to the greens and reds because I think the contrast and color worked pretty good there. So we got greater than or equal to -x plus 2. So I'm going to go a little quicker here. Greater than or equal to -x plus 2. So it's a solid line that has a slope of -1. Remember, negative slopes go down and to the right. And then it's a greater than or equal to, so that's why we had a solid line. And then we shade above it. So anything over in this direction would be true. And then I'm going to switch my colors. We'll go back to the red. And now we have anything less than. Well, wait a minute here, x, negative x minus 2. So I come down here, and this is a dotted line. So we'll just do here. You'll notice they never intersect. So this is a no solution because they never share anything in common. There's no purple area that I could have shaded like I did on number 1. Okay. Next one, y is less than 2x. So that means we start right here at 0 because it's 2x plus 0. And I got a slope of 2x, so I go up 2 over 1. And it is a dotted line. So we're going to make this dotted because it's a less than. And things that are less than. Shade below over here. So any point below this line would satisfy the first equation. Switch to green. Anything greater than y is greater than a negative 3. So I'm going to make this dotted again. So my solutions, we're going to have a solution, and it's where they both intersect. So if you wanted to use a third color, you can. Sometimes people had a highlighter if we're doing this by hand, and they would highlight, but our solution is over here in this purple area. Okay, and last one that I'm going to do. Y is greater than or equal to negative 2x plus 1. So we come here, and it's going to be a solid line with a slope of negative 2. So we're going down 2 over 1, down 2 over 1. And then make it a solid line. And we have a solution with things that are greater. So we shade over here. And we took care of the equal to by making it a solid line. And then one more today. Y is greater than x plus 2. So I come here. A slope of 1, so we're going up 1 over 1. So I'll get some dots down here, and it's a dotted line. We have a dotted line like that, and it is, again, everything above. So this area here, I guess I'll do it purple one more time. You don't have to, as long as you know. I also have some students sometimes point right here and label it solutions right here. And because there's kind of different boxes. We have a box with nothing, a box with 1, a box with the other one, and then right here is our solutions. This only works for the green one. This only works over here for the red one. This works for neither of them. So our solution is right up here. Any point that I pick up here, so like 0, 4, 0, 5, those would be solutions that would work for both of these. So your last assignment before you review is to go 5 through 10. These ones here, remember you would have to solve them for y first. So you have 5 through 10. and upload pages 27 and 28 to show me that you did 1 through 4. So really, it's kind of 1 through 10. If you want to be technical. Have a great day, guys.